The purpose of this video tutorial is to show how the program Adept Builder considers transfers when calculating balance load percentage and how we can correctly account for those transfer loads when checking the balance loading. In this example, we have a 5-story structure, and we can see, looking at the 3D rendering, that we have a transfer condition at these 3 columns bearing on this thicker slab at the first elevated level. And in this example, we're going to focus mainly on this interior column. We'll ignore the 2 exteriors. So to begin, we're going to go down to that specific level using the Story Manager toolbar. And if I open the tendon display view, we can see we have some tendons here. So we have tendons basically on each of the grid lines. We have 15 times 2 grouping, so we have a total of 30 strands here where we have the transfer condition. And one thing to note is that when if we try to map banded tendons to a support line or a strip, the program only considers self-weight for that specific load when we map. So it does not consider any of the load above if you have a transfer condition. The only way to make that work in a roundabout way really is to increase the dead load percent for the balancing to something greater than 100% and determine what that needs to be initially when you size the tendons using the mapping tools at a independent level. These mapping tools on the tendon toolbar are applicable to single level tendon modeling. You can still model this multi-story building and map tendons at each independent level, but the mapping function really applies to what's happening at that specific level. So a lot of times we have to make educated decisions on what the tendons need to be initially, or if we're doing staged construction, what those tendons need to be for each independent stage prior to us actually running the analysis. We can again use that tool in an artificial way by increasing that percent balancing on the minimum end to determine a starting point. So for example, if I open up this design strip and if I open up this design strip and I map tendons to that strip, here we can enter a percent self-weight to balance greater than 100. It might be 200, 300% because we're having to account for all the load above that tendon. If we're doing staged construction, what we can do is we can actually set one tendon line for each independent stage. So I could have maybe 5 tendons passing through this zone. Tendon 1 would be stage 1, tendon 2 would represent stage 2, and for each of these tendons then we could turn those off and on using this consider and disregard. We could also turn off and on the levels above that are not being considered for that stage. So that's just a way to maintain a central model and being able to do a staged analysis within one model rather than having to maintain multiple models in the same for the same project. All right, so we'll turn off. We're going to go ahead and just disregard the strips. We're going to show how we can look at the balance loading. So the first thing we're going to do at a very basic level, we're going to go to single level mode. We have this open in single level mode. The model has been meshed already. There's some basic loading. There's 30 pounds per square foot dead load and 100 pounds per square foot live load. In this example, we're again analyzing only this level. So at this point, we're not considering any of the transfer loads. If I go ahead and analyze this particular level, I'm going to turn off the option to include vertical load takedown. So this means that any of the transfer loads are not being considered. We're going to go ahead and analyze that. And after we analyze that, we're going to go to strips. We're going to generate our design strips. So we have our design strips generated. Now we're going to go to FEM and we're going to design the design sections. So this is for a single level analysis. And I size these tendons in this central zone really just for the transfer condition, so that we're going to have basically overbalancing in this condition. If I turn on the balance loading and allow my maximum to be 100%, we can see we have so much balancing going on for these for this slab. Specifically here I kind of just threw in some tendons, and this is really not applicable, but here we have 318% balance loading. That's because we have a ton of tendons and we have very little load. We are not considering the transfer condition yet. So that's kind of our base level look at what the balance loading is. Now if I go to multiple level mode, and from multiple level mode I'm going to go ahead and I'll just turn on the mesh display so we can see all of the levels are meshed. We're going to go ahead and analyze the entire structure. So we'll analyze the structure, and after we analyze the structure we can now look back to the first elevated level. We're going to turn on the strips again. We'll just go ahead and display those strips. We can see the strips here, and rather than analyzing at a single level mode, I'm just going to designing at a single level mode. I'm just going to design these strips from the global solution. So if I go to FEM, design the design sections, we'll turn off the FEM display. Notice that the balance loading percentage is still the same. So the program is not considering these loads in the column that are transferred at this level when it calculates the balance loading. They're considered in the general analysis, and if you were to actually design this strip, you would see a spike there for the moment, but for balance loading it's not considered. So this is still the same percentage. Now if I go to that level again, and now I go to loading, add load, load takedown, and I bring those loads down from above, and I'll go ahead and turn those on and display so we can see them. They're just represented by point load. So here we have a very large point load. This is a live load, and then we also have two dead loads. One of the dead loads is the superimposed dead load from above. The other dead load is the self-weight, which is converted to a superimposed dead load for the purposes of transferring this. So now we're going to go ahead and rerun this level in single level mode, considering the load takedown. So the first pass we didn't consider, and now if I check that balance loading, we'll go ahead and design the sections. Now we see that we have a true representative check of what that balance loading is, considering the load takedown from above. So this is how we can check it. We have to go through the process of doing load takedown to a single level mode where we check the balance loading relative to not only the load at the level but also the transfer loads. And the program reports this percent balancing in terms of both self-weight and dead load, so a superimposed dead load. So it's the total dead load applied at that level. If you have any questions about this, please contact support@adaptsoft.com, or you can call us at 650-306-2410.